Hello student, this is Dhanjit and you are watching my YouTube channel Reaction Concept. Student, in this video we are going to discuss about abnormal molecular mass. This is our topic of discussion for today. Generally, this topic is generally used in case of colligative property. So when we discuss colligative property, we frequently use this term, Vant factor or abnormal molecular mass. So before going to the topic, abnormal molecular mass or Vant factor, we should know a precise brief about the colligative property. Okay. So what is colligative property? The property of a solution that depends upon the number of particles of the solution is called colligative property. So since colligative property depends upon the number of particles, if the number of particles of the solution varies or changes, then the colligative property of the solution also changes. Okay, a number of particles, it depends upon the type of solute also. It depends on type of solute. See, you see when you dissolving a solute like glucose C6H12O6, when you dissolve this solute in water, it will dissolve as a glucose. Okay, here you see one molecule of glucose giving you one molecule of glucose in the solution. But when you dissolve sodium chloride, then it will dissolve in water as a sodium ion cation and chloride anion. You see one molecule of sodium chloride giving you two number of particles. One is cation and other one is anion. Another example is there. When you dissolve carboxylic acid in benzene solution, then two carboxylic acid will dimerize. Okay, here you see two number of carboxylic acid or solute particle giving you one number of particles. You say different type of solute give you different number of particles in the solution. So in order to calculate the number of particles in the solution for a one molecule of the solute is generally characterized by the Vant factor. It is generally and it is denoted by I. Okay, this Vant factor is given by number of particles after dissociation or association divided by initial, this is given by number of particles after dissociation or association or divided by initial numbers of particles. This is the formula that we generally use to calculate the calculation of Vant factor. Okay, so for different type of solute we have different formula for Vant factor. Let us discuss for different type of solution the Vant factor. Let us first consider first type of solute, that is non-electrolyte. This kind of solute, for example glucose, urea, this kind of solutes are non-electrolyte. When you dissolve this kind of solute in a solvent like water, it doesn't undergo dissociation or association. This kind of process will not happen in such solution, such electrolyte. So for such solute, the I, that is Vant factor, is equal to 1. Okay, so for a non-electrolyte the Vant factor is 1. Let us consider second type of solute, where solute is a strong electrolyte. Strong electrolyte means it completely dissociates when you dissolve in a solvent. That is 100% dissociation is possible. Okay, suppose you consider a electrolyte like AXBY. It completely dissolves in water as a AY plus and BX minus. Okay, like this it will dissolve. You see, in this case the Vant factor is given by number of particles after dissociate X and Y, X plus Y, and initial number of particles you take in the initial state, that is 1. So it will be X plus Y. Therefore, since it is a strong electrolyte, it will completely dissociate, that is 100% dissociation is possible. Therefore you can denote it as I 100% or by small n. It is given by X plus Y. Okay, now we'll see Vant factor for third type of solute, that is a weak electrolyte. Weak electrolyte are those electrolytes which generally partially dissolve or partially dissolve in a solution. In such electrolyte, a factor is given that is called degree of dissociation. Degree of dissociation is given for weak electrolyte. In any problem, this factor will be given. It is generally denoted by alpha. This degree of dissociation is given by numbers of particles or molecules dissociated divided by initial number of particles. Initial numbers of particles. So if we consider number of particles dissociated as a X and initial number of particles as A, then we can write alpha equal to X by A or X equal to A alpha. Okay, here you consider a weak electrolyte that dissolve like this way, AXBY. It is a weak electrolyte. Okay, it is a weak electrolyte and its degree of dissociation is alpha. It will dissolve partially as AY plus and BX minus. Initially, at T equal to 0, the number of particles for this electrolyte is, if A, then it will be 0 and 0. Suppose at T second, number of particles dissociated is this much. The number of particles rested here is A alpha. Here it will A alpha. X into A alpha, Y into A alpha. In this case, the Vant factor I can be written as total number of particles after dissociation in the solution. These are this number of particles, this number of particles, and this number of particles. We have to add all these terms. So it will be A minus A alpha plus X into A alpha plus Y into A alpha divided by initial number of particles. Initially what we have taken? Initially we have taken a number of particles, so it will be A. So if we simplify this one, then it will come out as 1 plus X plus Y minus 1 into alpha. This x plus y can be written as n or I 100% for the electrolyte. Okay, so Vant factor for this we can write. I'm writing here since there is no space. Vant factor for a weak electrolyte like AXBY we can write as 1 plus I 100% minus 1 into alpha. Okay, this is the Vant factor for a weak electrolyte. Let us consider some example of weak electrolyte. Suppose NaCl is a weak electrolyte and its degree of dissociation here given as alpha. So Vant factor I here would be 1 plus I 100% minus 1 into alpha. So for NaCl the I 100% would be 2. So 1 plus 2 minus 1 into alpha. It will result as 1 into alpha. Okay, for this kind of solute, here it is degree of dissociation, it is given as alpha. It is a sulfuric acid. Okay, so Vant factor would be 1 plus I 100% minus 1 and alpha. So 1 plus here I 100% would be 3. 2 plus 1 3. Okay, x plus y minus 1 into alpha. So this will give you 1 plus 2 alpha. For a solute like this, aluminum sulfate, here x plus, here it is the x, it is 3 is the y. Okay, so I will be 1 plus I 100% minus 1 into alpha. So 1 into, here it is 2 plus 3, 5 minus 1 into alpha. So I would be here 1 plus 4 into alpha. This is how you have to calculate the Vant factor for weak electrolyte. Now we will see the Vant factor where condensation, or discuss about associative type of electrolyte. Okay, here the electrolyte will associate beside dissociate. In the former one and type 2 and 3 we have discussed that the electrolyte have been dissociate after dissolution. Okay, but in this case the electrolyte will be associate. You see n number of solute when will dissolve in a solvent, it will associate and give you a An type of compound. Here you see n number of particle here, a particle here associate to a An particle. Okay, here association takes place. Here also degree of association also given here. It is also denoted by alpha. It is given by number of particles associated divided by initial numbers of particles. Okay, if it is number of particle associated, if it is denoted by x, then initial number of particle, if it is x, then alpha, that is the degree of association, would be x by a, and x would be a into alpha. Okay, here you see if you initially take at 0 second a number of particles, okay, then here it will 0 number of particles. After t second this all have associated. Okay, suppose x number of particles have associated and give you x by n number of associated particle. So in place of x we can write a alpha. Okay, here it will a into a alpha. So in this case the degree Vant factor is given by total number of particles in the solution after association. This would be the addition of these two products. Okay, these two factors, a alpha plus A alpha divided by A. So it would be 1 plus 1 by n minus 1 into alpha. So for a particle which undergo association, the Vant factor is given by this equation, that is I equal to 1 plus 1 by n minus 1 whole into alpha, where n is the I 100% of the solute electrolyte. Okay, so guys, this is it for today's class. If you have any doubt, you can ask me in the comment section below. And if you are new to the channel, then subscribe our channel and press the bell icon also.